All right, let's tackle a huge question today. How do we know that the things we believe are actually, true? It's one of the biggest questions out there, and we're going to peel back the layers and see if we can find an answer.
I mean, think about it for a second. How do you really know the Earth is round? Have you personally been up to space to check it out? Probably not, right? You learned it from a teacher, or a book, or you saw those amazing pictures from NASA. And that simple question, well, it gets right to the very heart of how we build our knowledge. You see, our knowledge really comes in two main flavors. First, there's the stuff you know from your own personal experience, like you know a stove is hot because, ouch, you've touched one. But then there's this other thing called consensus knowledge. And for most of us, the whole round Earth thing, that falls squarely in this bucket. We accept it's true because, well, the experts, the scientists, and our entire culture agree on it. Okay, so let's dig into the problem of knowledge. But here's the thing, relying on these methods isn't always foolproof, not by a long shot. So how do we sort the solid, hard facts from the pretty shaky beliefs? This is where things get really interesting. Now, there's a fancy word for this, epistemology. Don't let it scare you off, though. It's basically just the science of knowing. Think of it as a toolkit that helps us question our own understanding and really figure out what it means to truly know something.
And really, epistemology boils down to asking these three core questions. It forces us to pop the hood on our own beliefs and ask, okay, is this belief actually justified? Is it true? And how can I be so sure? It's kind of like a mental workout for your brain, It keeps you sharp.
All right, now let's talk about some common traps in knowing, because our brains have these flawed mental shortcuts. See, the thing is, our brains are wired for efficiency. They love to take shortcuts. We use all these everyday methods to gather information, but the problem is these shortcuts can often lead us completely down the wrong path. So what's in our everyday but kind of unreliable toolkit? Well, you've got tradition, the whole "it's always been done this way" argument. We trust authority figures, sometimes without asking any questions. We go with our gut, our intuition. And hey, while these can be useful now and then, they are wide open to error because they let us bypass any real critical thought.
And here is a perfect example of that flawed thinking. You've heard this one, right? My luck is bound to change. This is the gambler's fallacy. Just because you've lost at the roulette table 10 times in a row doesn't magically mean you're due for a win. Sorry to say it, but your luck isn't some character in a story that's building to a climax. It's just probability. So this brings us to the big errors that are constantly tripping us up. First, there's inaccurate observation. We just plain misremember things or miss details. Then we overgeneralize. We take one or two experiences and apply them to everything. We also do what's called selective observation, which you've probably heard of as confirmation bias, where we only see what confirms what we already believe. And yeah, like we just saw with the gambler, we make totally illogical connections. Bottom line, our everyday toolkit is seriously flawed.
So, that leads to the million-dollar question, right? If our natural ways of knowing are so full of traps, how in the world can we do better?
Well, this is where we start forging a better path. And this is where science comes in. And I'm not talking about just test tubes and bubbling beakers in a lab. I mean science as a way of thinking, a really disciplined process for building knowledge that we can actually trust.
The scientific method is basically our best defense against all those errors we just talked about. It's this powerful combination of logical, structured reasoning mixed with actual empirical observation of the real world. The whole system is designed specifically to help us overcome our biases and keep them in check.
Okay, now we're going to look at two paths of discovery, top-down versus bottom-up. What's really interesting here is that there isn't just one single way to do science. When we're trying to figure something out, there are really two main paths we can take. Let's break them down.
The easiest way to think about this is top-down versus bottom-up. Deductive reasoning is top-down. It starts with a big, general idea or a theory and then tests it to see if it holds up. Inductive reasoning? It's the exact opposite. It's bottom-up. It starts with a bunch of small, specific observations and tries to build a bigger idea from them.
So let's walk through the deductive path, from theory to fact. We'll use a classic example. You start with the big theory. All humans are mortal. Okay, makes sense. Step 2, you form a hypothesis to test it. If Socrates is a human, then he must be mortal. And step 3, you observe and confirm. Yep, Socrates is human. Therefore, the conclusion is inescapable. He is mortal. See? Simple, logical, top-down.
Now let's try the inductive path from fact to theory. We're going to flip the whole thing on its head. For inductive reasoning, you start with no theory at all. You just observe, okay, Socrates died, Plato died, Aristotle died. Step 2, you start looking for a pattern. Hey, wait a minute, they were all human. And from those specific observations, you develop a brand new theory. All humans are mortal. See how that works? Bottom up.
Okay, so let's compare these two paths real quick. Deductive reasoning starts with a general theory, and its whole goal is to test that theory. That's why it's the go-to for quantitative research, where you're testing a hypothesis against a ton of data. Inductive reasoning, on the other hand, starts with specific observations, and its goal is to create a theory. This makes it absolutely essential for qualitative research, where you might be doing interviews or case studies, looking for new patterns to emerge.
But here's the most important part. The real key takeaway. These two aren't rivals, they're partners. They work together in a continuous cycle of discovery. Think about it. An inductive study might uncover a surprising new pattern, which creates a brand new theory. Then you can use deductive reasoning to rigorously test that theory. It's this powerful, repeating loop of knowledge.
So why does all this philosophical stuff matter? How does it go from philosophy to your newsfeed? Because this framework, it isn't just for academics in ivory towers or scientists in labs. It is a practical tool you can use every single day to make sense of the world, especially now, in this age of just constant information overload.
So here it is, your new critical thinking toolkit. The next time you're scrolling through your feed and you see an article or a news report, you can ask yourself, okay, where's this knowledge coming from? Is it consensus or someone's direct experience? You can try to spot the path. Are they building up a new theory from observations, or are they testing an existing one? And you can keep an eye out for those classic flaws, like overgeneralization or selective observation. Just remember, knowledge is a journey, not a destination. This is how you become a sharper, more critical thinker. Because in the end, it all comes down to this one simple question. The next time you see a study or a big headline, you'll know the first and most important question to ask. How do they know? Understanding this whole blueprint of belief empowers you to look at any claim and really dig in. And now you have the tools to start finding the answer for yourself.